Okay, so this is the fifth in a series. I'm probably going to go a bit over what I thought. And what is happening here is I just wanted to show a couple of the examples in the Java slides about solving problems using stacks. And this particular example is kind of nice because it's a very simple example of parsing. Oftentimes when there's a defined language or a defined structure, in this case open and closing of parentheses or curly braces or square brackets, then it's useful to be able to use a stack in order to effectively parse what's happening. And just what I said in class is I call these round ones parentheses. I call these curly braces braces or curly braces, and I call the square ones brackets. Okay, just a slightly different nomenclature. And the example that's on the screen now is right, you want to make sure that things open and close in the right order, and the top two have everything correct, and the bottom two have, bottom three have some problems, right? So the first one, the problem is probably that we have an open parenthesis before there's a closed parenthesis before there's an open, and then here it looks like those two at the end are swapped. We should have closed the curly brace before we close the parenthesis. And the last one is sort of the opposite of the first incorrect one. We need to close that parenthesis. And there's the code that checks to see whether things are matched, and it has the opening delimiters and then the closing delimiters in the right order, and it uses a stack called a linked stack, and it looks like it just uses push, it should use pop, and it should use it uses isEmpty, right? And then provided the buffer is empty at the end, we pop off everything we pushed on, then everything's matching. Right, and there's the pop operation there. There's the push operation there, and closing. Right, so this is just an index into each of the strings. And yeah, I think it's a kind of simple problem, but it lends itself nicely to use of a stack. And similar things are in matching HTML tags. For every for well-formed HTML, for every opening tag, we need a closed tag, right? Right. We need to make sure that there's a closing tag matching every opening tag. Now, most browsers will actually deal with a lot of those, will deal with errors like missing tags reasonably well, but things are tightening up a little bit, so you should look at making sure that those tags match. And I'm not going to go through the tag. The other example, and I suggest you go through this example yourself. The other example is this one for parsing an expression, right? We've got 14 is less than or equal to 4 minus 3 times 2 plus 7. And you can see how the pieces are coming together. The values are pushed onto a stack, and the operators are also on a stack, a separate stack, the yellow stack, right? And you can see some of that here, right? There's two stacks. There's the operator stack, op stack, and then there's the value stack, val stack. I'm not going to go through that in any more detail, but I suggest you have a look through it. And if you have questions about, ask either on the discussion forum in Blackboard or during class. Okay, I need to get on to the C++ slides next, but I'll do that in the next